Utah Lake Commission. Our agenda has been posted on the state website as required by state law. So follow that agenda as outlined. Copies of which are on the table when you entered. I'd like to welcome you all here today. Appreciate your efforts with being with us. We'd like to start by approving our consent agenda, which includes the minutes of our meeting held on June 23rd. These were sent out with the agenda last week. Has anybody had a chance to review those minutes? Is there a motion to approve the common consent agenda?
Motion to approve.
Thank you, Mayor Wilson, for motion to approve. Is there a second? Seconded by Mark C. Strand of Orem. Thank you. Any questions on the motion? Hearing none, I'll call for vote. All in favor say aye.
Aye.
Any opposed? Thank you. I'll turn the time to Eric Ellis, who will discuss the algae bloom on Utah Lake.
Okay, thanks so much everyone for coming, both the members of the public and our governing board. It's been a fascinating ride as we've gone through this most recent algae bloom. It appears to be subsiding. We're hopeful that the lake can get opened up here sometime in the next week or two. What's been most interesting to me is the discovery that it doesn't just impact us here in Utah Valley, but rather that this time especially, maybe even for the first time, it had an impact on water users downriver towards Salt Lake and Davis counties. And so it's something that we would like to discuss today. We'd like to look at the current information about the bloom that we have, and also discuss potential short-term and long-term solutions if we encounter such a thing again. And it's likely that we will. And so not only will those short-term solutions be good in the future, but also to have an open discussion where everyone can kind of, come to the table on some long-term solutions. There's lots of different players that have a role in what ends up in the lake. It isn't any one particular entity or group, but everybody probably has some wiggle room to help find solutions. We'd like to have some of our representative from the state, Mike McKell, and some of his colleagues have contacted me in the last couple of weeks, and they're interested in helping find a solution. They've thrown out ideas like loans, interest-free loans or low-interest loans that would help some of the treatment facilities come to the 2020 rural compliance early, help facilitate that process. But we're open, and so as we come to the public comment portion of this, we would be interested in hearing some of those ideas if you have any of those. And hopefully in the long run we can come to agreement on how to improve the lake as a recreational water resource, as a water resource for the downstream users, and be able to find some sort of consensus on finding those solutions. So without further ado, I will turn the time over to the next item on the agenda, and hopefully at the end we can hear some of your comments on what you've heard, but I think that we'll get a good round of discussion through the three presentations that we have scheduled today.
Members of the Commission and audience, my name is Walt Baker. I'm the Director of the Utah Division of Water Quality. On this agenda item, we've got me and Erica Gaddis, one of the Deputy Directors of the Division, as spearheaded my agency's response to the algal bloom. Erica's not here. She said something about investigating water quality on a raft on a river somewhere. I don't know whether to believe that or not, but she had quite a week last week, and she's had a long-standing family vacation. So Jody Gardberg and I, Jody leads our water quality management section. Those are the folks that have been doing most of the investigation work, the assessment of the algal bloom and steering the monitoring. So Jody's gonna tee things up first, and then she'll hand it off to me to finish up, and we'll have a round of questions if anybody would like to ask questions. Later, Jeff Loster-Miller from Jody's staff will present some options of where we go from here. So Jody, why don't you take it from here?
Thank you, Rob.
Here's,
Good morning,
let me give you this.
everyone. Thank you. All right. So I'm going to step you through a timeline of what happened. On July 13th, we got a report from State Parks that there was a bloom on Utah Lake. And the bloom was reported from a recreational user to State Parks. We immediately sent out a crew to investigate and confirm the bloom. And we saw not only an algal bloom, a large algal bloom, blue-green algal bloom, on Utah Lake at the State Park Harbor, but we also saw a slick of the bloom. We collected samples. It had a putrid smell, and it was extensive. It was as bad as we've seen. On July 14th, we put together a monitoring plan, and we had a very big sampling effort. We wanted to confirm the bloom, and we got back cell counts of a certain type of cyanobacteria called Aphanosaunomon, and it was greater than 10 million cells. That triggered, from our guidance from the Department of State Health and the Division of Water Quality Guidance, for the local health department, the Utah County Health Department, to issue a closure of the lake. On July 15th, on July 15th, we had the closure. At the same time, we had a Department of Agriculture. They issued an advisory because not only were there irrigated canals coming off the Utah Lake, there were also canals coming off the Jordan River. That closure, it wasn't a closure, but it was an advisory stating that that irrigators should avoid using the water for crops and for livestock watering. We got hundreds of calls, and after the closure of the lake, we also got 300 calls on one day to the Poison Control Center, and 20% of people were experiencing adverse health effects due to the algal bloom. On July 16th, on the July 15th, when we did the monitoring, we also had aerial reconnaissance to see where the bloom was. And it showed that the algal bloom, while dissipating, it was also moving into the Jordan River. So we decided to we started to take samples on both Jordan River and Utah Lake, an extensive sampling effort with Salt Lake County and Salt Lake City, and we found that cell count data was showing greater than 700,000. 100,000 is when we issue warnings, and we say that it could be a moderate to high health risk. And so then the Salt Lake County issued warnings, danger warnings for Jordan River. And there was a series of closures of the canals. We had a canal, get all the canals here. We had Riverton City, West Jordan, South Jordan, and the Oak Lake was closed, and secondary water to Daybreak was closed. On July 18th was when the municipality shut down the secondary water supply, and then we started to have guidance for secondary water users. We were concerned about especially concerned about sprinkler irrigation from the aerosol. People can inhale the cyanobacteria, And again, to warn secondary water users, irrigators, to not use the water. And then lastly, on July 19th, there was a Jordan River closure and the Utah Lake closure. And I'm going to bring us to today. Let me show you some pictures. These are satellite images that are flown every week. And you can see on July 2nd, we didn't have evidence of bloom, but on July 11th, we did. And then 2 days later, that's when we got the report that there was an algal bloom. As you can see, I don't know, does this work? This one, okay. As you, here, this one. As you can see, the algal bloom was on the primarily on the east side here, and at the outlet of Provo Bay. We saw the highest levels here at the State Park Harbor, but it eventually moved, and that's why we do aerial reconnaissance, so we can see where the bloom is and we can target it with our samples. Algal blooms have an effect on the ecosystem. Algal cells, cyanobacteria, or these cells, are difficult for bugs and the ecosystem to digest. It's like they liken it to a cow eating, instead of a cow eating grass, a cow eating a tree. And so there can be not only ecological effects, but there can also be economic effects, as we're seeing, in the lack of recreation. The algal slick was 19 kilometers long and 30 to 50 meters wide. This is on July 13th. That was that first day. We took the sampling crew, took the boat out, and you can see how thick it is, and that putrid smell. And afterwards, we started wearing masks and really gearing up because of the effect it could have to our sampling crews. This is the aerial reconnaissance. You can see the algal bloom concentrated near the harbor. And then on July 15th, when we went out 2 days later, we weren't seeing the bloom. But these blooms have the ability, the cyanobacteria have the ability to sink and float and move with the wind. And so let's not be fooled when we don't even see it. Not only that, is when these cells die and we say lyse or rupture, they release the toxins. So we have to be vigilant even though we may not see it. July 15th, reconnaissance. These are a little bit hard to see. You can see the algal bloom. It had shifted to the northeast harbor. And this is, so we take two types of samples when we do this. The initial samples are cell counts. That means the amount of these cells in a concentration of water. And those cell counts, they tell us a lot. One, if you have an enormous concentration of these cells in the water, you're likely to get the adverse health effect. You're likely to get a serious rash. If you ingest it, you'll have gastrointestinal problems. And the more cells that you have in a concentration of water indicates the presence and the probable presence of cyanobacteria. Those initial cell counts and species identification tell us how severe this bloom may be and what types of management actions we should take. Then, a couple days later, those cell counts and species identification take 2 days to process. Then we send off the samples to a laboratory in Florida. We were using EPA's laboratory, but they were overwhelmed. We send it to this laboratory in Florida, and then they can tell us what toxins are present. The two species that we found on Utah Lake were toxin-producing species. So we were concerned about that, and we were concerned about the levels. As you can see on July 14th and 16th, the levels were great. They were so great, we hadn't seen this before, and it was unprecedented in size. Let's see if I can. So you can see it was, the algal bloom was concentrated about the state harbor at the mouth of Provo Bay and at Lincoln Beach. We also saw that we had high cell concentrations in the Jordan River, and there's a lot of canals that come off the east and west of the Jordan River for secondary water. There's also secondary water irrigation systems coming off of Utah Lake. And now you see recent data. The bloom appears to be dissipating. We're no longer worried. Well, we're less worried on the Jordan River. The advisory from the Department of Agriculture has been lifted, but we still have very high levels on Lincoln Beach, so we're being vigilant about that. Let's talk about cyanobacteria and the toxins. So cyanobacteria are also called blue-green algae, but they're not algae. They're prokaryotes and bacteria, and they produce 4 types of toxins: liver toxins, skin toxins, nervous system toxins, and three types of toxins. Sorry about that. We don't know all the species are out there. We know some of these ones, and the ones that we know of are Dolichospermia, are the ones that we found in Utah Lake. They produce liver toxins and nerve toxins. The toxins are microcystins, antitoxin A, and saxitoxins. The most common is microcystis. They produce microcystin or liver toxins. We have Cylindrospermopsis, nodularian, which is usually occurs in brackish waters and is the primary species in Harmony Bay, and Aphanizomenon, which is the one that we also saw in Utah Lake, which can produce nerve and liver toxins. So you can see why we were concerned when we saw that there were Dolichospermia toxins in Aphanizomenon. In 2014, Utah Lake had an algal bloom, and since then we've developed this guidance with the Department of Health and a harmful algal bloom program so that we can be proactive and have organization when a bloom comes in. The guidance states that, and it's off of cell counts. Remember, cell counts are our first samples that we take. We send them off to the Rushforth Laboratory here in Provo. And the cell counts are 20 to 100,000 is low to moderate. And that's when we issue the caution signs. And we have skin irritation, gastrointestinal illnesses. And there's reports of as low as 20,000 people having adverse health effects. The next step is our moderate to high. That's when we post warning signs, and that's 100,000 to a million cells. Remember the first samples that we took from Utah Lake at Lincoln Beach and the State Harbor, it was 37 million cells, to give you some reference. Now we're having samples that are less than 100,000. And then greater than 10 million, that's very high, and that's when the guidance says to issue a closure. Now, the responsibility of issuing either warning or danger and closures is the local health departments. And so our role and our partners' role, Drinking Water, Division of Wildlife Resources, state parks, is to give the local health departments the information they need to protect human health and our animals. Animals are also very susceptible to cyanobacteria because they lap in the water and they get it on their fur and then they lick off the fur, and so they have a higher possibility of ingestion. So again, on the 15th is when the local health department issued the closure to keep out of the lake. and it's still present. Again, this is an overview of our toxin samples. We sent off the toxin samples originally to EPA. The EPA lab, again, was overwhelmed, and we didn't get our initial samples till 5 days later. You know, a lot can happen in 5 days, but that's the quickest they could do. And it came back as a non-detect. However, the sample wasn't properly stored, so we were waiting for the next round of samples. That's when we decided to go with Green Water Laboratory in Florida, and we saw on the whole, mostly this type of bacteria was not producing toxins. However, we did have a very high concentration at Lincoln Beach. The recreational standard for these toxins is 20 micrograms per liter. We got 176 micrograms per liter. The drinking water standard, now this did not affect drinking water in any way. However, the drinking water standard is 1.6 micrograms per liter, and most of the samples were below that. So the only sample microcystin, which is a liver toxin, we found at Lincoln Beach. And as you saw on that previous map, Lincoln Beach is where the algal bloom is kind of residing. Since the 19th, we've seen, and hopefully it'll continue to do so, we've seen the bloom dissipate. We did have a total of 600 calls in total to the Poison Control Center, where we're asking all veterinarians and doctors to call if they have patients that have adverse health effects, gastrointestinal, again, dermal, vomiting, and we, and about 30% of those calls are people who did have adverse health effects from swimming or dogs in the water. We're also investigating how we're going to pay for all this. We all went out and we just took the samples necessary and to give you the information to protect human health. But these toxin analyses are very expensive, and so we in the labs were overwhelmed with the number of samples that we're sending them. So now we've gone to a weekly sampling regime to get an idea of the extent of the bloom, which we now think is dissipating. What about the Jordan River? So you can see in this aerial photo on the 16th, when we did aerial reconnaissance, we saw that the bloom was going into the Jordan River. We started taking extensive samples on the Jordan River and saw that we had levels that were 700,000 cells per milliliter, and we got very concerned. That's when the health department, Salt Lake County Health Department, Utah County Health Department issued warning and danger signs. You can see the extensive canaling coming off the Jordan River, and a lot of municipalities shut down these canals because of that. They're now open, and people have been advised that it's okay to irrigate their crops and provide water for livestock. Also, at the time when it happened in the beginning, the Department of Agriculture, after they put out their advisory, was helping folks get tankers out to their livestock to water them. Again, pictures of the lake outlet. You can see the bloom going into the Jordan River. This is an overview of the Poison Control Center. 81% were human exposure. We had 4% of animal exposures. It was mostly dogs, but we had a gaggle of geese. We had a horse that was sick. In one of the canals, they lifted up a tree, and there was 100 dead ducks. So those things will be investigated, and they were investigated by the Fish and Wildlife Service.
I think we'd be quick to say we can't connect the dots on the dead ducks.
Yes.
So they're sending carcasses in for necropsy. Was it avian botulism? Was it something else? We don't know. So we don't want to speculate there, but reports are coming in about goats and animal exposure and sickness, and that's just another part of the list.
Thank you, Bob. So, we asked the Water Quality Board at the last Water Quality Board meeting for money because we wanted funds in order to be more predictive of these harmful algorithms. And they granted us this money to put out buoys, so we'll have real-time data and we'll know we'll hopefully know that the bloom is coming before it does and have an early warning sign. We had ordered the equipment and this bloom came earlier than expected. And so we should have these buoys out in a couple of weeks.
Can I say something on that too? We've been knocking on the legislature's door for these sonds for the last 2 years, and we never made the cut list. In fact, we were so far away from the cut list that we kind of read the writing on the wall and sought then the funding from the Water Quality Board to move ahead with this. We have been notified as well that we can purchase 3 other data sondes that we can put out on Farmington Bay or put them in other locales throughout the state. Those have not been ordered yet, but similarly, they'll be predictive of when the circumstances and the conditions are right for harmful algal blooms. It's not going to solve the problem, but we'll have a little bit of a heads up to be able to marshal the resources, get ready, and be on our toes to be a little bit ahead of the game.
So how does this bloom compare to blooms that have happened in the past? You can see usually in October or late in the season, September, October is when we get harmful algal blooms. This came much earlier, and I'm going to talk about the conditions that are right for these algal blooms. So we looked at past data, and we saw we only had data to 2008, and because we didn't have people report these blooms in the past, we wanted to see, well, what were the concentrations at least of these cells in the water in past data, and we found that this is unprecedented scope and size to compare, especially to 2014 when we did have an algal bloom reported and we could monitor it or we could take samples from it. You'll notice that on this graph we have a log scale because the samples were so high compared to the past that we had to have it and this is 10 times those increments in order to even show the data.
Does the water level at the lake have any bearing on the algae bloom?
It absolutely does, and I'm going to talk about the conditions in a second.
Jody, can you go back and explain the dots, the bars, the boxes, the arrows?
Absolutely, absolutely. These are box plots, and these are median concentrations in the black line, and then you have the 75% and the 25% of the data. So 75% of the data is covered in this, and then 25% is here. The black lines are not standard deviations in this case. They're, it's hard to explain, they're statistical bounds to the data. And these are the larger sample sizes that don't fit into the statistical test. And so you'll see we had 37 million up here. On the median, we had just below 1 million.
So those top two, you talked about the concentrations of the cell counts in the water.
Yes.
Those are surface ones, those top two, are they not?
Some of, those are surface ones. We also take integrated samples.
Right, so if you look
Yeah.
at the integrated samples, don't they fall in your 75% box?
Yes, they do.
So those top two are surface samples, not integrated water samples, is that correct?
Yes. So we do two types of samples. We take a bottle, we do the surface scum, and then we also take ones that are up to the elbow.
Don't you think that that kind of skews the data though, for the water, integrated water sample?
We want to get an idea, see the cells, they float and sink, and so we want to get an idea of what's in the water column. But we also want to get an idea of what's on the surface, because that's where.
But those are windrows concentrated samples, are they not?
Yeah, but that's.
But they're still in.
I'm not saying
yeah.
that they're not, they don't exist, I'm not saying that.
Yeah,
I'm saying that the lake is a huge water body, and now you're skimming the surface where the wind has concentrated the cells. And so I'm looking at that data set there and seeing that it's tight and nice and tight in your box. 75, because 75% of the data is within the box set, right?
yes.
So your higher two outside, as a scientist, I would say, why is that data, why doesn't it fall in the data set? And my explanation would be because it's concentrated and doesn't represent the whole lake as a whole. I'm not saying it doesn't exist.
Mhm.
I'm just saying there's an explanation why it's an outlier, not why it doesn't exist. I'm not saying that.
Right, right. You can turn.
Okay.
Yeah, yeah.
The central concern is, relates to exposure pathways. And if you're a dog recreating along the beach, or if you're a person
Well,
swimming on the water, you're going to be exposed to the surface, most likely at your most likely point of ingestion, right? So the reason why the World Health Organization has.
Oh, I'm
levels-
not
Okay.
disputing that,
Yeah.
but that surface that you're getting, that water is inches deep, because you're walking out from the surface, and you're probably getting up to your ankles.
Well, we had some that were that high, some of the outliers were the surface in the open water too.
Yeah.
Okay, so
Yeah.
if I look at it, if I look at your data set, I'm not trying to take up too much time here, but when you say that the high counts back in your original photo, you were showing the Provo Bay and high counts that were there, that you're misrepresenting your position, because the graphs don't show that, and the data doesn't show that. So I think you're kind of painting a picture of how bad the lake is. And yes, you're doing a good job of that, but you're not also, I mean, if I look at your surface ones, Utah Lake State Park Marina, and you do have the one that is at the Scum Lake 2 miles west of the park, so, I'm giving you that. I'm not saying that's not true, but I'm just saying that you see the box, and you're trying to describe this, 75% of the data is below the 1 million. And that's what I understand from this graph.
Great point. The million was the integrated samples, mostly. However, 1 million cells per milliliter is still a serious.
I'm not saying that that's not bad. I'm just saying that you keep touting the 37, 32 million, where the majority of the data is below the 1 million. That's how we should understand this graph. And we should also understand this graph's kind of trending upward. I think that's what's important here.
Right?
I'm not saying that. I'm just saying that you keep telling this is way terrible bad, and it keeps being bad publicity on the lake. That's kind of what I'm doing.
Okay, right. I'm going to move on just because we have a lot to cover. But thank you for that comment. Can it get worse? The conditions that are right for cyanobacteria or harmful algal blooms are ones of low water.
Was that a 2006 photo you just showed me?
Yep.
I mean, that looks
Yeah.
worse than the one we just looked at.
Yes.
There you go.
And so the point of this map, this is the Landsat images, we decided to go back in time to see if there were indeed blooms that happened that we didn't capture in our data set, and this was one of them in 2006. There was an algal bloom. Again, the conditions that are conducive to these harmful algal blooms are ones of low nutrients, are ones that where you have low water. So this year Utah Lake is 4 feet down than average. You have very hot temperatures, and you have calm conditions, meaning no winds. And we're probably seeing that this harmful algal bloom happened earlier because we had those conditions in the last 2 weeks. Also, the conditions are water bodies that have a lot of nutrients in them. So if you have a water body with a lot of nutrients, low water, hot temperatures, calm conditions, we'll see harmful algal blooms. And Walt's going to talk about that more in just a minute. This is our decision-making flow chart for the local health departments in which to issue caution signs, warning signs, and danger signs. But it's also when we would remove signs, as we're doing now. We like to see 2 clean samples, cell count samples, and toxin samples before we do that. And that is our guidance to the local health departments. And lastly, this is, again, the conditions that are right for these cyanobacterial blooms. Low water, you have internal nutrient loading, external nutrient loading, hot temperatures, and a long growing season. So Walt, would you like to?
Okay.
Okay, so advanced, right, and then the little dot. The little dot at the top is
The LASIK surgery button?
yeah.
All right, I'm just going to take it from here. A takeaway message, I think, for this whole thing is, while we've experienced algal blooms before, we've seen pictures of that, in 2014 we're aware, this is an abnormal situation this year. And this is not unique to Utah Lake. We've seen this across the country. If you've read the papers, the 4 counties in Florida declared disaster areas, that's occurring there on a much larger scale than we're seeing. Lake Erie, you can read a Washington Post article today. The New York Times had articles last week. You can see coastal issues on the West Coast. You can see the areas off the Gulf of Mexico. You can see Chesapeake Bay, and on and on and on and on. So what is causing this phenomenon? You know, we can only speculate. We can talk about what the circumstances are here in Utah that we think are contributing to this. These algal blooms are tough to get your arms around, to understand them. When is it toxic? When is it not toxic? When is it just green algae, not a problem? When is it blue-green algae, potentially a problem? Just to look at the sources of nutrients, and in this you will see the wastewater treatment plants in Utah County. All of them are mechanical plants except for Salem is a lagoon, and it's a minimal component of the total loading to Utah Lake. We'll put this on our website too. You can take pictures of it if you want, but we can give you can have access to that there. So you've got 2, first of all, before I get into what these numbers mean, these are the contributors, as we understand, to nutrients. You've got a stormwater element, runoff from our lawns and gardens that we fertilize, and we add phosphorus and nitrogen that will go into our stormwater systems and eventually be discharged to the watershed. agricultural runoff, not as prevalent as it used to be because the efforts taken in the 1970s and 1980s to control non-point source and ag-related runoff that was coming down our river system into Utah Lake. And the fact is, our best crops anymore are houses and children. And so we're turning and converting our ag lands into an urban environment. And natural background, there can be phosphorus, we have phosphate mines in the west, natural phosphorus in the soil. But the largest contribution, according to the studies that we've done, of nutrients to Utah Lake are our wastewater treatment plants. And that's you and me. The wastewater treatment plants have not been designed primarily to remove nutrients. Some do a better job of it than others, but since the inception of the Clean Water Act in 1972, nutrient removal was never an element of permits for any wastewater treatment plant in Utah. There are really only one or maybe two that have that element in their permits now. And that comes as a consequence of a TMDL that was done in Snyderville Basin, and so they've got a nutrient limit. None of the other wastewater treatment plants in the state, including these around Utah Lake, have a nutrient limit. You can see, however, we understand, because we now have in permits the requirement for all wastewater treatment plants in the state to monitor their nutrient input. This is not a new phenomenon that with nutrient pollution, excess nutrients, that we're experiencing now. This has been an ongoing problem, and 6 years ago we established a nutrient core team to begin looking at how we can control nutrients going into our waters. So the numbers that you see here, we have our phosphorus and nitrogen loadings, the phosphorus being the lower number on top, the nitrogen loadings. These are in terms of tons per year. So from these wastewater treatment plants, with the exception of Salem, we've got 1,159 tons per year of phosphorus going into our system, as well as or nitrogen, and 231 tons per year of phosphorus going into our system. Nutrients are a good thing. We take supplements to have nutrients. In excess, nutrients are not a good thing. And they will do to a lake system and our waters what nutrients do to our lawns and gardens. It'll turn them green, it'll make them grow. And as a consequence of that, we can experience problems.
Was that this last year's?
That's current loadings. This will give you a perspective of today, what the flows are, and what we are going to see in the years to come. And it is entire. And this is saying we don't change our treatment. We keep treating to our secondary treatment standards. We don't remove more. This is what the population trends are going to tell us. So you can see, as we look out to 2060, as the folks at Water Resources are doing, so that we have sufficient water, we're going to have populations in this Utah Lake Basin approaching 1.5, but 1.2 to 1.4. We can see, it says Utah secondary standards, when they came into being, actually it was sooner than 1980, when the Clean Water Act came into being, and we put secondary treatment, minimal, that's the lowest, that's the required of all wastewater treatment plants to remove BOD, suspended solids, disinfect our water so that we don't have E. coli. Those are the minimum standards, and they apply across the country, regardless of whether you're Moab discharging wastewater into the Colorado River, which they could discharge raw wastewater. You probably couldn't move the dial on the water quality. It doesn't make any difference. You got to meet that minimum bar. So the minimum bar is what we've been meeting. And now some plants do a little bit better and a little worse, but the minimum bar is what it is. If that minimum bar does not change, then you can see with 176% growth rate that we're going to experience from now until the year 2060, our loads are going to go up, our population is going to go up, our treated wastewater amount is going to go up, and a commensurate increase in the amount of nutrients that we're going to be discharging into the system. Right now, these are the inflows, the major inflows to Utah Lake. The publicly owned treatment works in 2010, 13.5% of the water that goes into that lake is treated wastewater. That's treated wastewater, so that's better than what's coming into the plant. These plants can do remarkably well at removing some pollutants. They do not do remarkably well, all of them, at removing nitrogen and phosphorus. Some better than others. So in the year 2050, 1/4 of the water in Utah Lake is going to be wastewater. If you look at what the Jordan River will be with the larger treatment plants along the Jordan River, and in certainly low flow conditions, it will be an effluent dominated stream. In other words, more water will be from our wastewater treatment plants in the Jordan River complex than the imported water that we're bringing in from other sources. That cannot be sustained at the level of treatment that we are providing right now at these wastewater treatment plants. What's the loading? This is the loading of phosphorus in pounds per day, and I'm going to talk about what this line is here and what that means. We have seen this problem coming for some time, and the first two elements of our nutrient control strategy, the first one is developing site-specific limits for our headwaters. In other words, criteria that will protect those waters, because that's where we draw our drinking water from. Those are our precious water resources in this very arid state, and we want to protect those. Plus, it's easier to do those because there are no wastewater treatment plants up there. Nobody's ox particularly gets gored by having effluent or having water quality standards protecting those headwaters. So we're doing that. We anticipate in the spring that we will then be rolling these out for public comment. The second phase of our strategy is to develop what's called a technology-based effluent limit for phosphorus, and we've done that. And that means by January 1, 2020, this rule went into effect in 2014, so providing 5+ years to all the mechanical wastewater treatment plants in the state to hit 1 milligram per liter for phosphorus. That's about a 2/3 reduction in the amount of phosphorus that these plants are discharging right now. It will make a significant dent in the amount of fertilizer that's going into our waters. So that's effectively drawing the line here that we're going to hold the line. Is that going to be good enough? It is not going to be good enough in many circumstances, but it is an adaptive, modest approach that we feel that technology is there to do that. And what you do is you add chemicals to allow the precipitation of the phosphorus out, bind it up, and then remove it in the normal filtration process, settling processes that we have at our wastewater treatment plants. Some plants are able to meet that right now. Orem is able to meet, I believe, anybody from Orem City here right now? Orem, what are we doing? Do you have any idea, Reed? A wastewater treatment plant, what are we hitting right now? Yeah.
We're at about 1 and
Maybe just a hair
1 and 5
above that.
point. Yeah.
And so some plants are doing better than others at meeting that. And so the purpose of that technology-based limit is when you find yourself in a hole, you quit digging, and we want to quit digging on as far as the nutrients that we're
The
contributing.
brown columns,
Pardon me?
on that, what were the brown columns?
Well, this is 2020. What we're looking at building up to hold the line. So this is 1 milligram per liter. As population increases, that's really what will hold the line on the amount of pounds per day for the phosphorus loading. We did a cost study. Even before this economic benefit study, 2 years before, in 2010, we did a cost study because we saw this is coming. How much is it going to cost the average Utah household to, in sewer fee increases, to be able to hit this mark? We identified in that cost study that it would be approximately $120 million to get down to the 1 milligram per liter. Some treatment plants can do it for pennies a month added to their sewer bill. Some are going to add $3.50, $4 a month to get there because of the different complexities of the treatment. A companion study to that was the economic benefit. What kind of value do we put on our water resources? And are we willing to pay to have lesser nutrients in our system? This study was done by the University of Wyoming in tandem with Utah State University, with CH2M Hill, who had done our original nutrient cost study, doing what the benefits are. So the takeaway is we value our water. Now there's no surprise there. We're willing to pay to keep our water as good as it is now and improve it. And we're willing to pay significantly for that because it is part of our quality of life. What's the economic value of our water? And it was identified in that range. Will removing this food source accomplish anything? Some will say that it won't. It's wasted money to remove phosphorus and nitrogen from our treatment plants, so we ought not do anything. I'll talk about a study that we're engaging on right now that we've initiated that will address that issue and lay it to rest once and for all. But this is a picture at Deer Creek Reservoir back in the 70s. We had problems in Deer Creek then. That's green. We could have called it Green Reservoir, not Deer Creek Reservoir. And this is what this looks like in the 90s and into today. It's a drinking water source, it's a recreational source, and it does not any longer look like this. There are ways to remove, and it is shown nationally, to control the amount of algae and reduce it so that we can restore our waters to where they need to be. I can show you East Canyon, similar type of situation. We discount the notion that Utah Lake is different and can't do anything about it. We do not believe that is a unique water body in the state of Utah, nor nationally, and it's been demonstrated that there are steps to be taken. Okay, we know that if we don't invest in our bridges, sometimes this is what happens. We have collapses, the infrastructure goes flat, the concrete falls away, you have failure because you haven't maintained and repaired and replaced. We know what happens if you don't do that with air quality. If you just let it go and try to say Mother Nature will do what she's going to do and will clean up things, that is not a proactive approach, and neither is it an approach for our waters. If the do-nothing option, in our opinion, is not a viable option, and it's going to take as much attention and investment as we look at things like the Bear River Pipeline and the Lake Powell Pipeline to provide the upstream water sources. We're going to need to be equally attentive to addressing what are the downstream effects of doing that. I want to talk just briefly, and we'll take then questions. We have embarked upon a Utah Lake study in 2015. How many stakeholders may have attended that initial kickoff meeting in the fall of 2015? We have some here that participated in that. So we've got as many stakeholders as that have got a stake in the lake that come to that meeting and help us chart the course. The first phase of that is a 3-year effort through the year 2019. That's the phase one, if you will, of that study. It is the data gathering to understand where the data gaps are so that we can make informed decisions. In the second phase, we will develop a model, a sophisticated model that is specific just to Utah Lake, that will understand the cycling of the phosphorus. How much is coming in, stormwater sources, ag sources. We think we got a pretty good idea about the public mineral treatment work sources, but what we don't have an idea on is how much phosphorus cycles in that lake. That it comes in and out of the sediment, in and out of the water column, how much is exported downstream. We saw evidence of that it is not a bathtub, that we export some of the problem down to Salt Lake County. We need to understand and model that to understand if we remove a percentage of the phosphorus, what will that effect be on the lake and what will that effect be downstream? And so that's going to be likely a 5-year effort from now through 2021 to be able to have that model in place. And effectively what that will do is allow us to come up with a site-specific standard for Utah Lake that will allow us to protect the recreational uses and the downstream uses for agriculture as well as our fishery uses for that lake. So we're on it. Each of us need to own it. This is not just one agency, it's just not my agency's problem. It's all of our collective problem, and it's going to take our collective attention if we're going to solve this problem. Our board, we're going to go to the Water Quality Board this next month. We've accelerated the schedule. We're going to petition the board for $1 million that the board has had in a lockbox for another study that now was not necessary for the Willard Perry treatment plant to remove more nutrients. The board locked $1 million away just in case that was necessary. We're going to petition the board to take that $1 million out and assist us with the funding of the Utah Lake study, including a very important element. The first thing, or one of the first things we need to do is core that lake and understand the historic contributions of nutrients. Is this lake, right now, is this what it's always been and always will be? That coring is going to help us understand what that lake has been, and that will drive then what the potential will be into the future. So I think that's Jody and I's presentation. We took a lot more time perhaps than we should have perhaps, but I'll take any questions.
My question is one phosphorus going to be enough? Provost, City Council is going to be considering ways to upgrade the facility.
Yeah.
And our concern is one enough?
No.
And so we don't want to go through and spend a lot of money to try to upgrade a facility where in 3 years we're going to have to get the site-specific results and then upgrade again.
Right.
So
one is not enough.
what is it going to need to be?
What's it going to need to be? I could probably, here's a map of, in the early 2000s, EPA identified eco-regional criteria for phosphorus and nitrogen. The standard for phosphorus and nitrogen is not like other standards that EPA develops. They do it for metals, they do it for inorganic compounds, they do it for a plethora of other pollutants, and we call those water quality standards. There's not a national water quality standard for nutrients because it is so site-specific. So the states have been left to their own devices to come up with criteria. We're doing that for our headwaters. We'll work our way down in a priority fashion to ultimately hit all the waters, but it is a multi-decade process to do that. So EPA came up with eco-regional criteria, said if you'd like to implement standards right now out of the gate, and some states did and embraced these eco-regional criteria, here are the numbers. Now this is the ambient water quality. In other words, you go out and see what the water is in your streams or your lakes and reservoirs for this ecosystem is the Western Forested Ecoregion, Wasatch and Uinta Mountains. For rivers and streams, the criteria that they would set is 0.01. That's not similar to the 1 milligram per liter out of the pipe at a wastewater treatment plant, but this says when that effluent is mixed in the water body, what would be the level of phosphorus that you would like to see? 0.01. For lakes and reservoirs, that's for streams, for lakes and reservoirs, it's half of that, 0.005. Absolutely can't meet that at the end of the wastewater treatment plant. But what we can do is, for instance, Snyderville Basin has got a limit of 0.1 for phosphorus in the pipe, and it can probably hit 0.05. It takes filtration, it takes a biological nutrient removal, it takes an anoxic zone, it takes a more sophisticated wastewater treatment plant than some of our plants, including Provost. Not really what we would call, you've got filters, correct, on the plant, which is a good thing, but it's an all-trickling filter, 60s technology, not dissimilar from Salt Lake City, from South Davis. It is going to take a ramp up to be able to
Well, we
hit
also
that.
have aeration basins, there wasn't enough data to set.
Pardon me?
We have the aeration basins, so they are not, we're not strictly a treatment filter system.
Provo is. So it's going to, back to your question, is one going to be enough? That is a minimalist approach. That was $120 million present value cost for the entire state. To take a more aggressive approach, it would be in the $1.4 billion present value to be able to hit that. And that could be a $15 a month increase in sewer bills in some communities, or as low as $5 in others. Please.
On that pie graph, you showed that Spanish Fork River was one of the main contributors to water to Utah Lake. It was probably like 40% of the water was coming into Utah Lake was from Spanish Fork. I do not believe that's the case as we speak today. Right now, it looks like there's only 1 or 2 CFS coming from Spanish Fork into Utah Lake.
Let's chat offline. I'm going from what the budget was back in 2010, I believe, on that.
Can I help you on that? It probably includes the leases from Strawberry Reservoir. The Strawberry Reservoir releases were not included. I have a question related to that.
Okay.
Is anyone looking at the releases from Strawberry and their effects this year on the temperature of the lake and how that may have affected the algae bloom?
Some agency may be, ours is not. So I do not know the effect of that release it would have on the temperature of Utah Lake.
Can I have a follow-on question? We know that it's starting to subside. Do we have a theory on the mechanism for its subsidence? Have we had enough wind disturbance to prevent light penetration, or what is the mechanism, and is that going to persist the rest of the summer? We don't.
Are you asking me if,
I'm
how the
kind of
weather
asking
is?
Jeff if he knows what the mechanism is for the subsidence.
Well, the winds did pick up. Algal blooms naturally, you know, they're organisms that them and actually consume them, bacteria, those kind of things. And so there is, you know, that's how they keep in check. But in this case, we did see some winds pick up, so that probably helped. But it could, you know, they didn't actually have these boom bust cycles, right? I mean, it's just, the problem is when you have the boom cycles occur for longer periods of time and more frequently. My guess is that, just a guess, hypothesis, that we'll likely see at least one more bloom this year, given how early it was. You know, the underlying conditions haven't gone away. We just need several days of calm weather and, you know.
Off we go again.
Yeah, I could comment a little bit on that too. I'm looking at the zooplankton in Utah Lake, and there's Daphnia in the lake. And Daphnia consume, I found a Phamnozomenon, and one Daphnia can consume 50,000 cells of a Phamnozomenon in 1 hour.
Yeah.
One individual Daphnia, they're trying to do the microbe. So in 10 hours, it can consume per liter 500,000 cells. So that's what the boom and bust, a lot of
Right,
this
yeah.
has to do with zooplankton.
Yeah.
So what's going on with the zooplankton, that could be that cycle thing we're seeing. Plus the wind, when it things up and break down the cells so that after you get that.
Yeah, I was gonna, you're totally right. I missed that, but, and you're also right that some cells are easier to eat than others.
Right.
And sometimes it requires the algae to become weakened in some way.
Well, thank you. We're, in the essence of time, we're going to move on to the next presentation.
Oh, I have one more question.
Wait a minute.
Yeah. Another question.
Well, in the Daphnia situation, are they affected by the cyanotoxin at all? 'Cause I know a lot of the freshwater crustaceans and mollusks that filter feed the algae, they're affected and they will die if they eat a lot of that stuff.
Oh, cyanotoxins are, according to the CDC, the most powerful natural poisons, period. And so all organisms are susceptible, but to varying degrees. Daphnia have co-evolved with cyanobacteria, which have been, they're among the most ancient organisms on the planet, right? So there's been a lot, so they're more tolerant than other organisms, but they still, everything has a toxicity when it comes to, neurotoxins.
One more thing, we do updates almost every night on Utah Lake and Jordan River. And please go to our website at dep.utah.gov and search for harmful algal blooms. You'll see the guidance, you'll see our sampling, our monitoring, maps, pictures, and you'll get those updates on where the bloom is and how it's dissipating, what signs, what bloom is.
Let's move on. Eric?
Yes, so we have a presentation by Agriculture.
So I'll do my best to make up for the time that Walt spent. But I know that was really important. I'm Melissa Yore. I'm a senior policy analyst for the Utah Department of Agriculture and Food. Commissioner Adams and Deputy Commissioner Scott Erickson apologized. They had prior commitments, and so they sent me instead. So I'm sorry, this is what you get. Immediately when we found out about the algal bloom on Utah Lake, we were immediately concerned about our agricultural producers. We do know that there are quite a few agricultural producers who draw water directly from Utah Lake, but also, as Jody explained about the canaling and the Jordan River, we honestly have a very limited idea of how many agricultural producers actually use Jordan River water, obviously because most of those are small backyard producers. They're using it to grow their garden, or they may have one or two animals in their backyards, which they use Jordan River water to water their animals. So the effects on agriculture are kind of hard to determine because we just don't know how many people are actually using all of that water. But the concern was there because we started with what we actually have solid knowledge of, and that, like Jody explained, is that this algae and the toxins produced by it do have a negative effect on animals. As she said, that animals are especially sensitive to it because they get in it, they then will lick themselves and clean themselves off, and those kind of things. So they're especially sensitive to it. We do know that dogs will die, horses die, cattle die, sheep, goats, and we have a large amount of producers who do, like I say, use Utah Lake water to water them. Water their animals. So that was our basis for issuing the advisory against livestock watering. Obviously, it's very dangerous for livestock to use that water. So that was a major concern that we had. We then had the additional questions that people would ask, well, I'm not necessarily using it to water my livestock, but I water my pasture with it. Should we continue to allow the water to be used for pasturing? And the facts are there is evidence that the bacteria and the toxins produced by it do last on the surface of plants for a period of time. We didn't know what that time period is yet. We're continuing to do research on that. So it was, if at all possible, please avoid using this water for irrigation purposes. That's part of that was for the animals consuming the crop, but then we were also concerned about this being on the surface of our fruits and vegetables. So if at all possible, we advised not to use that water. Now, that created a problem because where are you then going to get the water from? There needs to be an alternative source. And as we said, we did finally manage to get alternative sources of water for the livestock, but we still have the major concern about what we're going to do for our agricultural producers growing crops. There is some scientific evidence that this bacteria and the toxins have an effect on the plants themselves. There is possibility of it causing problems with the germination of seeds. It does affect the crop yield, and in fact, if in large portions of it, it could cause death to the crops themselves. There was the concern that the plants will uptake this and it will get to the fruits and the vegetables themselves, and so the toxins will reside in them. We have very, very little evidence that it actually gets to the fruit of the plant, that most likely the plant would die previously to it getting there. But in order to assure the public, we are actually doing testing of produce to see if there are toxins in this food. But like we said, there is very little evidence, but in order to reassure the public that we are doing that, we are sending our samples to the same lab in Florida, although we have been talking to a researcher in Colorado who says that she could probably do the same thing. So we're in talks with her about whether or not we can do that. Our major concern is when it comes to the crops is the perception that is now out there that if you have used this water to water your crops, that somehow your crops are tainted and that you shouldn't eat them because it's a human health risk. And like I said, that's one of the reasons we're doing the sampling, but there is actually really very limited evidence that it would ever affect the health and safety of the produce itself. Of course, wash your fruits and vegetables before you consume them. That's just a standard practice. There are all kinds of things in nature that could cause you to get sick if you don't do that. And Jeff, did you have something?
I think you said is absolutely correct. I would say that there is slightly more evidence that root crops and things like lettuce that can have a more direct pathway to what it is you're consuming than fruits that take a long time to grow.
Yeah, and that is a caveat. Leafy greens, those kind of things. And also the problem with that too is the delivery mechanism for the water itself. If you're flood irrigating, sprinkler irrigation, it does in fact increase the probability of at least contact with the bacteria and toxin on the fruits themselves. Of the uptake, we are sampling kale and those kind of things to make sure that it's not in those things currently. But yes, the method of delivery is important, but of course, again, please wash your fruits and vegetables before you eat them. But those were our major concerns. The perception out there that using this water is unsafe for fruits and vegetables is the major concern we're having right now. Of course, aside from we still have the advisory on for not letting your animals drink out of water taken directly from Utah Lake. So we've lifted the advisory for the Jordan River, but if you're taking directly from Utah Lake, we still advise not to have your animals drink directly from that water. So please find alternative sources. And of course, that's because it is very toxic for these animals. So.
Thank you.
Yeah.
Did you bring statistics to show the toxic levels when we had the last algae bloom 15 years ago and 30 years ago? Every time we get shallow, we have a high concentration of algae blooms, and I was wondering if you had the toxic...
I think we covered that before you came in, sir.
Yeah.
Oh, did you? I apologize.
Yeah.
That's been well covered with Mr. Baker's
Could you tell me what you
presentation.
found out?
Be happy to. We need to keep moving forward. We've got
Just one last question.
One
Any
more
toxic effect on the carp? I mean, again, we're killing off the animals we want. We kill off the ones we want killed off.
It does affect fish, but I'll leave that to the fish people to talk more in depth about that.
I'm just curious, I don't understand the toxins, but everybody keeps talking about water transportation. Are there other means by which they can be transported by, say, insects? I mean, we have a lot of horse flies, deer flies, I don't know, I'm just asking a question.
We did have a question about whether bees would have that affect the honey, because bees will get the water and transport it to their hives, but they're not going to transport it in enough that we considered there any concern for honey. So as other mosquitoes and pests like that, I will leave that to the scientific experts to answer that question, but I would say, in my opinion, there's very low risk of that taking place.
Bottom line is, you know, it's hard, people are mostly concerned about human health effects.
Yeah.
And the research even there is ongoing. I mean, these toxins are so toxic that laboratories don't want to produce them because they're really expensive. So to conduct toxicology tests, you're talking about spending, you know, thousands of dollars just to get the material that you need before you can start the experiment.
Yeah.
Other effects like agriculture are much more poorly understood.
We are also, just so you know, looking into whether our chemistry lab could do its own testing for fruits and vegetables. That's something we're looking into, so we no longer will have to send them out. Currently, it looks as if we do have the capabilities. It's just getting everything up and running and whether or not we have sufficient funding to do so.
Along a slightly different line, is there going to be testing once the all clear signal is reached to see if there's any toxicity level that's worked into the fish population of the lake by species or?
I'll let the fish people talk about that, but we are going to continue to do sampling of fruits and vegetables.
Broadly speaking, the fish tissue muscle that we eat is not where the toxins end up concentrating. It's
The innards and the
yeah,
oily,
right, stuff that you
like PCBs.
yeah.
Let's move on and talk about the short and long-term potentials.
Yeah, I'll try to catch up too. So what I'm talking about is just kind of an extension of this, but when all this started to happen, of course, the first question people ask is, well, what can we do? No one wants to just sit tight when these things are going on. You know, agriculture was being affected, recreation interests were being affected, and so we had a lot of members of the public asking us, well, is there anything we can do? You know, the answer is yes, as Walt spoke about over the long term, but there are also potentially short-term remedies, all of which have advantages and disadvantages I'll talk about in a second. In addition to the public calling, we also started to get over a whole lot, and quite a few calls from different companies who were offering their services to help solve these kind of the short-term effects of these blooms. On the order of 5 to 6 calls, contacts per day. So there's no shortage of people who want to help. The question is that a direction we want to take, and what would that involve? So before we can talk about how to solve these algae blooms, we need to talk about what causes them. It's already been covered. A lot of times, you know, people don't necessarily believe us. So this was a paper that was published. A group of over 100 experts in harmful algal blooms convened, and they asked each other questions about what do we know about these blooms, right? They came up with these 7 statements that they, as a unanimous consensus. So if you can get a room full of scientists to agree on anything, that's pretty amazing. They came up with 7 things that all of the people at the conference agreed to with respect to what we know about algal blooms. And a lot of what Walt talked about is on this list. Increased nutrients is important. External sources of nutrients are critical if you're going to sustain the kind of large blooms that we're mostly concerned about with respect to human health. Yeah.
Could you go back real quick and explain number 2 in a little more detail where?
Sorry, I'm trying to catch up.
I know. You're differentiating the composition and the quantity.
Yeah, so that means they agreed that the input of nutrients was important, that external sources of nutrients were required to sustain large blooms, but also the relative concentration of nitrogen and phosphorus can be particularly important. And that depends on the particular cyanobacteria species and a variety of things. But it's absolutely true that you can't just be worried about the quantity of nutrients, you also have to be worried about the ratio of the macronutrients. So when we talk about long-term solutions, such as what Walt was discussing, you know, we think about these watershed management solutions. And ultimately, that is the long-term solution to restoring the condition of the lake to as good of a condition as it can be. But there are also water body specific management controls that can be taken, and that's largely what I'm going to talk about today. And the idea there is that over the short term, you just suppress these algal blooms and or efforts to remove or remove nutrients at a local level, so within the lake itself. So there are a variety of advantages and disadvantages to these kind of watershed scale versus water body scale kind of management options, and I think that they both can really work together. I mean, if we're looking at 2020 before these phosphorus limits were to be implemented, that's going to take some time. It's also, there's internal loading considerations. That's probably going to take some time to work its way through. So in the interim, are we willing to have 5+ years where we have these algal blooms occurring on a somewhat regular basis? And if not, is there something we can do over the short term? And so, you know, there are some advantages to these water body specific, mostly that they're more immediate. They can be cost effective. People have been doing these kind of treatments since at least the early 70s, some further back, but that's when they became more widespread, I think. And more research is going on all the time in terms of technologies that can be used. There are a lot of new technologies out there that are largely untested at larger scales, especially when you talk about large lakes like Utah Lake, as opposed to small lakes or ponds. I help my brother manage some private water skiing ponds, and it's a lot easier to control the effects of his algal blooms than it is in a large lake. And the studies that have been done demonstrate that what works at one scale doesn't necessarily scale up to another. So that's just a consideration as we're looking at different options. And so what I sort of, to simplify that, so what we're talking about is a Band-Aid over the short term while we work on these long-term solutions towards really getting at these problems long term. And so when we're looking at, when we're looking at the options that are available, you know, we have to think carefully about not just what's most likely to be effective, what are the costs of the various options, but also what are the unforeseen consequences, what we call non-target effects. So you can have, for instance, if you kill all the algae at once, then you create a carbon source, the microbes consume that carbon, and then that creates oxygen depletion. So sometimes when people go in and they control algae, all of a sudden they get a fish kill. So that's something to avoid, particularly in a circumstance like Utah Lake, where you have an endangered fish species, the June sucker. The Fish and Wildlife Service is actually making moves that things continue to go well to, you know, move from endangered to threatened, which would be a huge deal for Utah. So we don't want to do anything to mess that up. And I think that, you know, we also need to realize that, you know, trying to treat an entire lake might not be reasonable or even advisable, but we can try some of these things at smaller scales, try to control them, just try to keep things potentially from getting as large as they previously, or they were in this particular event. So as I've been getting all these calls, you know, you get lots of people calling you and everyone's got the solution that is a silver bullet that's going to solve all of our problems. And so, you know, we had to have a mechanism of trying to screen through these. You want to keep an open mind, but at the same time you want to address the sales calls with a healthy dose of skepticism, especially if the tests are not well documented to be effective. So like I said, some of these treatments go back to the 70s. We know well that they can work and what some of the disadvantages of them are. Others are more experimental. And so I did a pretty extensive literature review. There are some pretty good reports out there, you know, just to give you a sense of how many treatment options might be available. 250 pages evaluating one option to the next, advantages, disadvantages, costs, likelihood of success, where they're most likely to be successful, et cetera. So these are all just considerations that we think about what to do if we were interested in addressing these at a short scale. Here are some of the compendiums are in that second list, being compiled by other countries, other states, and us, the United States, and then a lot of other scientific papers and that sort of thing. And so what I've sort of presentation, I'm just going to breeze through kind of at a 10,000 foot scale the options that have been demonstrated to have been useful for short-term control of these things, algal blooms, in the literature. So the first, well, not totally, but, so these are kind of what I consider, I think about hammers from a ping hammer to a sledgehammer. These are sort of physical controls that, for the most part, are unlikely to have as many negative consequences. In some cases, they might have secondary or ancillary positive consequences. So some examples of physical controls would be aeration, which is depicted in this photo. There are things, solar-powered devices that you can put in that create artificial circulation. So we talked earlier about wind being an important factor. What these things do is make it so the lake feels windy all the time because they're moving the water around. But again, in a lake this big and this shallow, there are some practical logistics that would need to be evaluated before something like this would go on. And so what these things do is encourage competitors like Daphnia and zooplankton and bacteria. They also discourage the cyanobacteria conditions by keeping water moving and creating conditions that other organisms can outcompete them. So again, these are pretty well demonstrated. You can, yeah, so and you can see this is a before and after picture from Florida where they added some aeration and circulation systems. And actually it's interesting that when the Provo Bay restoration project was going on, one of the recommendations made by the Fish and Wildlife Service was to add aeration to the bay, specifically to encourage the June sucker. So that gets at some of these ancillary benefits that could happen should we decide to pursue something like this. But again, for the most part, the large-scale demonstrations of these kind of technologies have been on smaller lakes and or deeper lakes. And so there are some other considerations we need to have. So I mentioned I was helping my brother manage his lake. We use a tried and true technique, which I think is a pretty non-invasive technique in some ways. You use a food grade dye. You can use blue dyes or black dyes. They like blue because it kind of looks like the Caribbean. But all that does is add shading. It keeps and we've had remarkable results for him. That's been demonstrated elsewhere. I talked to some folks that work on lake restorations and have been doing so for decades. They assure me that you could, should you decide you wanted to, dye Utah Lake within a couple of days. Now that treatment in particular works best if you get ahead of the algal bloom. Once it's already going and it's kicking and you have a big bloom, it's not as likely to be effective. And so, again, but there are disadvantages because you'd be removing the overall primary production of the lake and have food web. Yeah.
Doesn't the natural turbidity of the lake limit the light penetration anyway?
Yes, that's true. But when we have these algal blooms is when when we have calm conditions, right? So what you're trying to do in this case would be accomplishing the same thing, but during calm conditions when the blooms were to occur, where you're going to get started. I'm not promoting necessarily any of these things. I'm just trying to say, people ask me, are there things that could be done? And I'm trying to let you know what some of the options are. Some of the newer technologies involve using things like ultrasonics. That actually disrupts the membranes of the algae cells and can prevent algae from growing altogether. This is newer technology. It's just starting to scale up to be demonstrated in larger lakes. There are 3 or 4 papers demonstrating its effectiveness. So these are all pros and cons. Whether or not you think the pretty blue color, artificial color, is a good thing or a bad thing probably would depend on who you ask. But the dyes are biodegradable, so it's a temporary thing. So again, with all these things, you have the potential for non-target effects, and in this case, you're affecting both cyanobacteria with those treatments, and also the beneficial algae which support the food web. And so you got to be really careful about unforeseen consequences. Probably the most widespread control is, and irrigators know this, they use these things all the time, our drinking water plants and their smaller holding reservoirs, they use these treatments to control algae, and that's the application of pesticides. The most common pesticides are copper formulations. There are a whole bunch of other possibilities, and they're also newly developing some organic options that are plant-derived compounds that people think might have less sort of secondary or non-target effects. This has been done for a long time, and we know that they work. We also know that especially if used long-term, many of these things can have some very negative consequences to the ecosystem. But they do work quickly. So if you want to knock out an algal bloom, go and add an algicide, it kills the algae. So that's one advantage, and the chemicals are getting safer and safer all the time. We've had some bids on what it would cost to do either the Jordan River or Utah Lake, should we want to pursue some of these things. But again, we would need sort of a charge to explore this further. The biggest concern that we have with these compounds, particularly copper, is that it's toxic. That's the reason it works. And it's not just toxic to algae, it's toxic to all organisms. We have water quality standards for copper, right? Now, algae happen to be particularly sensitive to it, and which is why people feel, why it has been applied safely, at least over the short term. But if it starts to accumulate in the ecosystem, you can have problems. Plus, if we were to do this every year, say during the algal bloom season, the other problem you can have, the biggest, worst case scenario, unforeseen consequence, cyanobacteria being bacteria, not actually algae, the way their genetics works in reproduction, they can actually adapt to changing conditions pretty quickly. And there is lots of evidence in the literature where you have copper treatments, particularly that have been applied over a long period of time, and what ends up happening is the cyanobacteria become immune to the copper, and then the other organisms aren't becoming immune to the copper, and you actually can shift your ecosystem to a cyanobacteria dominance where it was only that way for short periods of time before. So that's kind of worst case scenario, unforeseen consequences. But again, all these things we just got to be really careful, I think. The other options are flocculants. Walt mentioned this. It's the same kind of process that, say, a treatment plant might use. To remove the algae itself, you add a variety of different things that can grab onto the algae and cause it to settle. Again, the depth of Utah Lake might be an issue there. But the cool part about flocculants is there are some that have been developed. They can actually not just grab algae, but they grab phosphorus. And some of these compounds can grab phosphorus and also bind it so tightly that it's really unlikely to be released under the conditions we experience in Utah Lake. So there's a product, I'll show you in a second, called Phoslock, for instance. And so when we get to studying Utah Lake and the relative influence of external inputs versus internal inputs, if we do find that internal cycling is preventing us from seeing the kind of benefits we would like to see, Phoslock is a product that's been demonstrated to be really effective in getting that control to take place. As one product. I'm just not promoting any product, that's just the one that I know of. So there are advantages and disadvantages. One big disadvantage, probably the biggest, is that these kind of treatments are extremely expensive. And there are some data limitations with regards to their application in this kind of environment. They've been done a lot more in oceans, actually, and then really smaller ponds, so we're kind of in between. But it might be worth exploring, at least on a small scale, particularly with respect to the ability to deal with both algae and phosphorus, one of the underlying causes. So there are other proposals we've received. I've had a number of phone calls from people proposing microbial treatments, and they're enthusiastic about these treatments and their potential to solve our problems. Suffice it to say that I can't find anything in the literature. I found two papers where these have been kind of approaches have been evaluated, one in a lab, one in the field. In neither case were they able to demonstrate a positive effect. The companies have lots of benefits, and I've been asking them to provide me data to demonstrate these benefits, and so far I haven't received them. But again, I'm trying to keep an open mind. These are more natural kind of solutions that have some possibility, but just the main point here is that people are becoming more and more innovative with regards to controlling these things as harmful algae blooms become more widespread, more intense, and a greater problem around the world. So if we were going to do this, any of these things or other things that I haven't mentioned, there are some real important, I think, logistical considerations. First and foremost, there are lots of people, as demonstrated by those in this room, who have a stake in this in one way or another. and we need to figure out a way to make sure that our action that we might be doing to control a harmful algal bloom wasn't going to counteract, say, what the Division of Wildlife Resources or U.S. Fish and Wildlife Service were doing to restore the Juma sucker. And so we need to figure out how to get the right people together to kind of evaluate the pros and cons and trade-offs of these things. And that is going to take some time. So the reason I mention that is because the one advantage that these kind of treatments might have, again, is an ability to respond to an emergency situation. So like, say, agriculture wouldn't be immediately effective. We can deal with the short-term effects. I wouldn't recommend doing any of these things long-term. If you do that, you're going to have, long-term consequences that are probably worse than we're seeing today. But it is a potential short-term fix, again, a Band-Aid. But if we're going to be able to apply them in an emergency, we've got to figure out what we're going to do, who needs to be involved, where is the cost benefit, and have a plan for making that happen. And so now that we're beyond this bloom, another one might happen this year, but we're never going to get a plan if we don't start. And so, it's easy for people to, I get 6 phone calls a day, plus now, 2 weeks from now, if we don't get another bloom, I'll probably get 0, right? It's the focus, and if we're going to do this, we just need to maintain the energy, I guess. And so then associated with those groups, there are a bunch of, regulatory considerations, permitting and that sort of thing. But I also think it's important to, again, as Walt was speaking to think longer term. We're all part of the problem. We all need to be part of the solution. We can point fingers as to, I'm more of a problem than you are, or we can all just say, hey, what can we do to reduce our part of the problem? And the reality is that multiple approaches are likely going to be necessary. And I'm going to bring up carp. I know people have been doing a marvelous job of getting carp, which are a detrimental, species to this ecosystem in a variety of ways. There are a lot of studies that have demonstrated that if you're really going to see major benefits in a lake that has high nutrients already, especially shallow lakes that has carp, you've got to simultaneously remove nutrients and address carp. Doing one or the other is probably not going to get you where you want to go. Now, one possibility, and I mention it just because it is a possibility. So when I first found out about the Carpet Noodle Project, this is me, not GWQ, my first concern was that, well, are we going to be creating an algal bloom problem, knowing that ambient nutrient concentrations were high in the lake, and that turbidity was an issue, and that carp keep lakes turbid. I was wondering whether removing the carp without also addressing the nutrients couldn't cause a problem that we knew already existed to get worse. And I don't know whether that's can be explained in terms of the most recent algal blooms or not, but I don't want to suggest that we shouldn't be removing carp either, because again, they have lots of negative consequences. But I am saying that we can't expect to find one silver bullet that's going to fix a problem that's been, we've taken 100+ years to create. It's going to take some time, and we're going to have to likely use a multifaceted kind of restoration or remediation approach. But again, going back to what Walt was saying, I am convinced that it's possible based on evidence that we've seen elsewhere in similar kind of ecosystems around the world. So, anyway, summary, lots of options are available, all have advantages and disadvantages. The cost of these things, just to give you an idea of some of the people who put numbers on these sorts of things. We got for chemical treatment, say for a bloom like this, for Fatal Lake and Jordan River, about $200,000 a piece for a single algal bloom, $250,000. Some of the other approaches are on the order of just over $1 million. And again, these are all just short-term fixes. So we're just going to be putting these rather expensive, but maybe not expensive in comparison to all the costs associated with recreation loss in agriculture. We're just going to be continuing to buy Band-Aids as opposed to, fixing the disease or curing the disease, I guess. But there are some real, very real short-term consequences, and if we want to fix them, we can explore doing that. And I think I have one more slide. So this is late last night as I was thinking about how we might move forward with this if we wanted to explore some of these options. You know, first identifying, well, what waters are we interested in treating? Are we talking Utah Lake? That's probably a more tough nut to crack, I guess, than say the other extreme, which would be some of the smaller reservoirs that the irrigation providers use to provide crops, right? That might be an easier fix. We know more about how to solve algal blooms and those kind of systems. But once we've identified the waters, identifying who we need to have at the table, starting to look at the various options, ranking them in some way based on their likelihood of success, cost, and potential secondary or non-target effects, you know, selecting the actions, and also the criteria that we would have to see before we would want to implement an action. So once we've done all this, we can work that plan in, say, with the U.S. Fish and Wildlife Service and their Endangered Species Emergency Consultation process. We can have the process established, we can have the permitting established, we can have whatever regulatory requirements are necessary done, have identified a source of funding to pay for whatever treatments we wanted to do. All that's necessary if we're going to make this work. And that's all got to happen before the emergency occurs. Because once the emergency is going on, I guarantee you there are not enough resources to be able to think about doing something new. And so it's a short-term fix, but it's going to require some careful long-term planning if we wanted to explore it further. I think that's all.
Thank you,
Any other
Jeff.
questions?
One comment. If we're working with an open mind here, I've got the silver bullet. So tackle the 90%, 1,000% initiative. We reduce the surface area by 90%, increase the depth by 1,000%, going from 3 feet to 30 feet. So we just shrink the lake to a small lake, increase the depth. The rest of the land around it will be wetlands, water coming in, and start to get
Okay. I did mention in my options hydrologic modifications, which people use, right? And I mean, I suspect if we did something like that, you're right, probably. It would be. I don't know which people we would want to have at the table. but you know, the people have tried similar things. I mean, these are a big enough problem. You know, people that haven't, states that haven't addressed these problems, have a longer history of it and more nutrient inputs. Kansas, you talk to those folks, they're closing lakes or parts of lakes all over their state all summer long, every single year. And that's the case in, you know, so that's, if we don't address the problem like Walt was discussing, you know, we can ultimately get there. And I don't think, at least I'd like to see us go there, you know, biased. But I think, you know, 97% of Utahns said that that's not where they wanted to see us go for future generations either. So,
Thank you, Jeff. Let's move on to communications plan. Who's got that one?
Right here. Nathan Schubuck.
Do you have the? I can go off of yours, it's fine. It was a minimal change, but not a big deal. Okay. In fact, do you have access to your email?
Jeff, while they're setting that up, a dosing, if you were to dose, you know, if you were to use some kind of toxicant that would kill the algae, is that a once a season thing? Is that a twice a season? Is that a?
It depends on the compound you're using. The one that's been proposed to us, supposedly, it's a balance because this particular product stays in the water column until it's taken up by the algae, right? It's an advantage in terms of longer term effects. But that means you have to dose it at a higher concentration to begin with, which is a disadvantage in terms of affecting other organisms, right? So initially, say like early life stages of the June sucker, for instance, say in an extreme example. So that's the balance they try to strike, is how to give just enough to kill the algae, not enough to harm other things, but you want to have enough residual left that you aren't dosing and killing the algae and then having the same problem bounce back 2 weeks later, right? So they, I guess, short answer, probably it's not a once a season kind of, well, it depends on when the season starts. If it was a normal season where we're only dealing with it for 6 weeks or so, maybe that would be enough. This season, probably, you know, we're gonna not have any of the residual effects of the herbicide after, say, 3 to 4 weeks with dosing, then recommend.
While you're setting up, can I ask you questions? You're still setting up.
Sure.
We showed the 2006 algae bloom photograph, and I remember that algae bloom.
Okay.
And I remember that it was not cyanobacteria, or very little of it was.
Okay.
And the question I would have, is there a mitigation where you could encourage the preferential algae to
Yes.
grow in anticipation of blocking the cyanobacteria?
That's a really good question. And yes, and it's actually what I mean, if I were to start, what I would say, well, these are options I would explore earlier, would be things that would have secondary benefits for the fish and other beneficial algae. Aeration, increases in circulation, those kind of things discourage cyanobacteria growth and actually can encourage green algae to flourish to the point where they can outcompete cyanobacteria from occurring. That's pretty well.
So we get our recreational boaters out there and just have them spin around.
That's a possibility.
Spin fast.
You joke about that. The water was too low for people to want to go out there getting the problems.
Yeah. I've only been out a couple of times myself.
Yeah. I didn't dare go out this year at all. I didn't dare go out because it's too shallow.
I took a chance. We made it. And that was when we dredged the harbor, maybe we would have prevented this. They were supposed to do it last
While they're setting up, let me take a moment and remind the board, our next meeting is August 25th at the Utah County Health and Justice Building in room 2500. After that, it's November 17th of 2016, and we'll finish out our year. I'd like to go around the table if I can and get general comments from the board members. If anyone has comments to make at this time, we'll try and get this moving forward so we can end on time. Any comments from the board? All right, are you ready, Nathan?
Yes.
Okay.
So real quickly, my name is Nathan Schwabach. I'm the Communications Director for the Department of Natural Resources. For about the last year, we've been working with Ben Holcomb and his team at DEQ to start addressing and formulating some of the communication challenges that would come with the harmful algal bloom. In those meetings are several entities, DEQ, DNR, Wildlife Resources, Ag, and many others. First and foremost, nothing trumps public safety, which is why the department has been very supportive of the efforts that have been made to this point to close the lake and to address the algal bloom issue. This also, though, has caused us to look at the communication mechanisms in which we use to communicate challenges with the algal bloom, but also perception that arises with it. So I always say, one of the things I always say is perception is reality. And with many different organizations playing in the sandbox together, that can become very challenging. What DEQ needs and wants to communicate is very different than what DNR might communicate. Whereas they're scientific based, some of the things that we need to take into consideration are how are we communicating it in a way to where we don't cause unnecessary panic, or that someone understands the true nature of the challenge we're facing and their perception isn't skewed to the point where that perception becomes their reality. So what people perceive is usually what they believe, and this is based on what they hear, see, and think. One of the things here, Pat Bagley from the Salt Lake Tribune, I'm sure some of you follow him. I don't want to focus on the state lands issue, that's a whole nother topic, but what I found interesting was how he perceives Utah Lake. And what does green communicate to us? Green communicates that it's toxic, it's dirty, it's disgusting. And if you look at public perception, now some of you may say, well, you could thumb through tweets and posts and comments on comment boards, and you could dig long enough and you're going to find negative perception. The reality is it took me about 2 minutes to find these comments because they're everywhere. Things like it's a nasty lake. It's caused from what's being dumped into the lake over the last century. That's nasty. It's hot and there's poop in the water. Those are the misconceptions of Utah Lake. But the reality is that's the reality we have to play under and that we have to start addressing when we look at communication efforts. Twitter, again, Pat Bagley is very prominent. He's been very vocal on this issue, but we're poisoning Utah Lake. It's a dangerous algal bloom. Now, one thing to keep in mind is it's the algal bloom that's toxic, right? It's not the lake that's toxic. It's the algal bloom, and so when that algal bloom is gone, then it's appropriate and okay to recreate on that body of water. So though an algal bloom covers 90% of Utah Lake, its toxicity is on the rise. So again, that's referring to the lake. It's big, it's green, it's Utah Lake, it's poop-driven. It's a poop-driven algal bloom. So how we communicate becomes critical because we have to address misconceptions that exist. So one of the things, it's not what you say, but what people hear that matters. I remember in working with this particular issue, one of the challenges that we've had is being able to formulate messaging that will resonate with the public and also be very forthright and truthful, because that's important in this case. We have to get accurate and correct information out there. This press release, one of the big challenges we had in back and forth dialogue between Donna Spangler, Larry Lewis, and some of the other PIOs involved was when we talk about wastewater, what are we really talking about? Because the perception is if you just say, well, we dump wastewater into Utah Lake, that's poop. That's what a common person with a 5th grade reading level, which is what we deal with on a day-to-day basis, is going to assume. So we need to make sure that our perceptions match reality and that is treated water from these treatment plants that is discharged into Utah Lake. So many different ways in which we communicate that. This press release, you'll see in the headline, does not mention toxic. The first draft did. And these, again, this back and forth, some of the dialogue that we had as PIOs as to what is appropriate and at given times. So in every communication effort that we have on an issue like this or any issue we face as PIOs, we have to consider our communication through the eyes of the audience in which we're communicating with. That's very different. You know, when we talk in this setting, we can talk more science-based. We can talk some of those elements, and we all know and understand what's being discussed. Again, an average recreator who may come out and jet ski or boat on Utah Lake or fish or hang out at one of the beaches or marinas, they're not going to view some of the language we use in the same way. So this is an ongoing discussion that we're going to have as PIOs, and I view this personally as a learning experience. We've gone through it. There's some areas where we need better collaboration and to streamline our messages more appropriately. But the reality is we're making progress. A couple questions that I would ask is, how does public perception differ from reality? I think we kind of talked a little bit about that. You have treated wastewater, which is sent into the lake, is very different than feces. Very different. But there is some of that reality. Is the bloom toxic or is the water toxic? I imagine from a scientific standpoint, Walt, there's probably some debate and discussion we could have about that. But But again, what is it that we're talking about? And missed in all of this, in the algal bloom and all the discussions that are happening, is what has been done in the past to help the lake become more healthy. There are efforts. We talked about carp removal. We've talked about where we haven't talked, but there are other things, Phragmite removal, intake, restoration and improvement projects that have been taking place. So there's a lot of positive things that have happened on the lake over time. There's a lot of positive things that will continue to happen. Another question we have to start asking ourselves is this the new norm? And based on what I'm learning and studying of this issue, I would have to say the likelihood of seeing more algal blooms in the future exists. So we'll need to tighten up and figure out how we communicate that appropriately to the public, again, without causing unnecessary panic. So how does public perception differ? Some of the things, poop filled, I guess I can, feces, whatever it might be, wastewater, toxic, nasty, deadly, all these words that people are using in comment sections that it doesn't take me much effort to find, shows what the perception of Utah Lake may be. Early on in this discussion, we had a meeting here, Eric Ellis was there, and we started talking about, okay, when this is lifted, what can we do immediately to try to get people energized or to recognize the value of Utah Lake and energized once again to recreate. And the comment was made, all the good work we've done is down the drain. I can't believe that. I have to believe that the public, if we give them the information, will consume it and understand it, that, yeah, there's challenges with the lake. We'll overcome those challenges. There's science behind it, and efforts will be made to make a difference. But also the good work that has been done is making improvements on the lake. So how do we change perception? By communicating reality more effectively and by doing it together. There are a ton of stakeholders involved with this, both from the state level down to individual communities. What I hope to do and what Eric Ellis and I have been talking about is we need to get these PIOs in a room. We need to enhance messaging platform and get everybody kind of in a cohesive, pointing in the same direction. And then through proactive and collaborative communication. So a couple things. What do we do short term? What do we do long term? It's a balancing act that we have to do. We get PIOs in the room. We begin coordinating messaging platforms. And what this is we have experience now. We know what some of the sticking points with the public are in regards to maybe where they misunderstand reality of things, and they need some additional educating for this. The role of wastewater treatment plants in generating nutrients. That's an area where I believe more education is needed. The difference between a harmful algal bloom and algae. I think a lay person is not going to understand those, and this actually generates more and more concern and questions from the Department of Natural Resources when we think about what if something is detected or seen at Jordanelle, because many bodies of water have algae. What if something is seen there, they just assume it's a harmful algal bloom, and we, of course, go down the road of testing and different things, but it causes unnecessary worry and concern because it turns out to be normal. So short term, we coordinate messaging with different agencies. Proactive public outreach. There are events and community-driven events that happen all the time on the lake. We need to do a better job promoting those and doing it collectively to where we support each other. Utah Lake Commission has a Facebook page, has a Twitter feed. There's no reason that the Department of Natural Resources or Environmental Quality or American Fork can't also share that same information out, and we work together to get the word out on things. Health of the lake. We should be talking more about the science, and when solutions come, presenting those solutions. Good work that's been done, carp removal, intake improvements, Phragmite improvements, all these different things should be communicated in the media, all the different things that we do to increase the health of the lake. And then, again, stakeholder support. More long-term, it's the same type of thing, working together as PIOs and communication teams. What my hope today for cities or conservancy districts or other groups that are here today is to please encourage your PIOs to get in touch with Eric Ellis and myself And we're going to begin coordinating meetings and start down the road of better collaboration as we work towards addressing some of the misconceptions. But again, this idea of a collective communication plan, one of the things we do at DNR is our divisions have communication plans on an annual basis, and those plans are updated regularly. A lake the size of Utah Lake and with as many parties and stakeholders as it has should also have a communication plan where we collaboratively work together on that. Types of things we promote there are events, community benefits, science and improvements, and then part of the solution. Algal blooms, harmful algal blooms are a part of Utah Lake. And so recognizing that, publicizing and promoting the good work that's being done to help mitigate those and to address long-term solutions will be valuable, and the public will recognize that. And then ongoing stakeholder support, again, working together as a group. That's a kind of a real quick and dirty version to help us get caught up a little bit, but what my hope and intent is to help us see that perception. We're not necessarily dealing with reality, we're dealing with perception. And we need to begin taking steps from a public relations or media relations standpoint to begin changing that perception of the lake or bringing it back up to where it was prior to this particular algal bloom. Any questions? Go ahead.
I was pointing maybe to the group. Are there opportunities where you could conduct surveys or focus groups, based on meetings and things that already exist, to better understand where those disconnects between reality and perception really lie, and what kind of messages might do a better job of making perception more closely aligned with reality?
So what you might do in a marketing world, and I want to avoid that a little bit because this isn't about spin, this is about being factual and educational, but from a marketing world, what you would do is you would test messaging. And so there are ways where we could invest money into surveys and focus groups and do that. But with the prevalence of social media, we can also collect good data based on media audits that we perform, which is where I see these comments, performing these audits, but then also online surveys, which would give us much of the same data.
We have completed a survey at least once a couple of years ago, so we have that information drawn as well. So.
You had a question, sir?
Yeah, it's not going to be very noteworthy when the lake is clear to go back and recreate on it. Are there efforts to promote the news agencies to put that out there?
Yeah, and that's one of the things we met here last week about to discuss is what can we do collectively to host an event or do something that would generate some added publicity on the fact that the lake is open, different recreational opportunities that are available on the lake. And so those discussions are happening. The reality is there are individuals, corporations, and businesses that rely on the lake for their personal well-being. And so it is part of our responsibility to make sure that we're advocating for and promoting those.
I'm a mayor in Salt Lake County in Riverton. Don't forget us. I know as I read historically, there's friction between Utah County and Salt Lake County sometimes on this issue. You've got our full attention with the tremendous economic issue that comes with it. In Riverton, we're the only city in Salt Lake County that has a secondary system to every home. We need Utah Lake. It can't be replaced. And I would just say, involve our PIO. I'm happy to do anything I can politically and in every other way.
Great.
And so, I think it's a time.
Would you consider joining the commission?
I would, if the invitation was given, but yes, I think I think that Salt Lake County, particularly the west side where the canals are, we're ready. And if we're not, we better be kicked so that we are ready. So we have a great deal invested here.
So I'm a Harriman resident, so I'm just next door, so I will make sure and DEQ, while we're plugging Harriman real quick, I mean, anything we can do to get Black Ridge reopened, my kids would be grateful.
So that is important too, important to our water supply. Yeah. Any way we can help.
Nathan, thank you very much. In keeping with the time restraints that many of us have, I'm going to ask the presenters to stay behind. We have a lot of people with questions and comments to make. I will give you the chance to talk to the people that made the presentations you have questions about, and we will conclude our meeting. Thank you very much.